today we are going to solve this number theory problem, and I want all of you to have a good look at this problem right now. This is given as p into p plus 1 plus q into q plus 1 equals to r whole into r plus 1, and we have to solve this equation where p, q, r are basically primes. Now a prime number is a number which has divisors only 1 and the number itself, such as 2, 3, 5, 13, like that. Now this is the type of question that you get asked in any olympiad or maybe in ISI CMI type exams where you have variants of this kind of question. These are called Diophantine equations. These are called Diophantine equations, and solving these equations is very hard, I would say that, because you are given 3 variables and you only have one equation to work with, and that is the magic of number theory. So let us begin. Now we are only given the equation and the information that these are primes, and that is sufficient to solve this problem like explicitly. You do not even need any other information. That is the crazy part here. So we start with first, because we see there is a factorization available to us, and in number theory you should always try to look for factorizations, because once you turn an equation into a factorizable form on both sides, you can then equate the factors based on some condition or the other, but you can equate them. Otherwise it is very hard to even proceed with the problem if you do not factorize it. So p into p plus 1 is equals to r into r plus 1 minus q into q plus 1 step here, and then you can simply break it like r square minus q square, and then take the common r minus q out of it to get this expression. Now why is it useful? Because we know p into p plus 1 where p is a prime and p plus 1 is obviously either even or odd depending on whether p is 2 or not, and then we have r minus q whole into r plus q plus 1 on the right hand side, but we have it in a factorizable form. Now since p is a prime, we can do this. Now since p, q are all primes, and since p into p plus 1 is greater than 0, and obviously this term is greater than 0, this term is greater than 0, which means this term must also be greater than 0, right? This means that this whole expression is greater than 0, which means that r should be greater than q, and that is something you might have also understood from the question itself, that r itself is greater than q, but okay, this is also a basic way to find this. And now we have this equation. Now since p is a prime, you see that p is a prime, which means p will divide exactly one of these factors. It cannot divide both, because if it does divide both, then you have to have that these are multiples of each other, which is not the case right now because these are primes, right? So p is a prime, then p will divide either r minus q or r plus q plus 1, and this is because whatever it divides, p plus 1 will be equal to the other factor, right? So we will check each case, because we cannot leave any case here, because that might lead to a solution, and we want to find a complete solution to the problem. So let's take the first case. If p is dividing r minus q, now if p divides this, then p must be lesser than or equal to r minus q. So if a divides b, then you can be sure that a is less than equals to b for positive integers. Okay, so this is the case. Now since p, r minus q, all of these are positives, so if p divides r minus q, then p must be less than equals to r minus q. Now what does this lead us to? This leads us to the fact that p plus 1 should then be less than equals to r minus q plus 1, and we're trying to show some kind of contradiction here basically. So now since p less than equals to r minus q and p plus 1 less than equals to this term, you can multiply both of them, because everything is positive on either side of these two inequalities, and if you multiply them you get this inequality where p into p plus 1 would be less than equals to r minus q whole into r minus q plus 1. Now you already know the value of p into p plus 1 from this equation, which means you can simply put it here and get r minus q into r plus q plus 1 less than equals to r minus q into r minus q plus 1. That is this equation. R minus q is positive, cancel it down and then simplify, and you simply get q is less than equals to 0, which is nothing but a false statement with regards to our question. That means that p cannot divide r minus q. If p divides r minus q, then we lead to a contradiction, right? It leads to a contradiction. So we conclude that p does not divide r minus q, so p must divide r plus q plus 1, right? Now if p divides r plus q plus 1, then we can say that r plus q plus 1 is some multiple of p. So we can conclude that r plus q plus 1 is k into p for some positive integer k. You can simply write k belongs to natural numbers here. Now there is something we need to put aside first, is the fact that k cannot be 1. That is important. Okay. So first of all, you put this value in the equation we have for p into p plus 1, and you simply get that p plus 1 is nothing but equal to k whole into r minus q. So which equation am I talking about? I am talking about this equation right here, right? Okay. So we simply get that p into p plus 1 is equals to k whole into r minus q. Now k greater than 1 must be true, because let's say if k was equal to 1, if it was true, then we must have that p plus 1 is r minus q from this equation, and we must also have that r plus q plus 1 is equal to p, correct? Because r plus q plus 1 was equal to p by putting it in the value of p into p plus 1 over the equation, right? And if you solve this too, you simply get q equals to minus 1, which is again a contradiction, right? Q is a prime and it's obviously a positive integer. So this means that we can rule out k equals to 1, and this was important. You should see why it was important in the coming part. So k greater than 1 must be true. Okay. Now there is something we need to do here, and this part may not be very obvious to you, but notice that we have found some expressions regarding r minus q and r plus q. And in solving this kind of problems in number theory, or specifically in Diophantine equations dealing with primes, we often try and take some specific sums or differences of these expressions, which leads to something trivial. So here you can see that r plus q and r minus q can be subtracted, and this gives you the result 2q, where 2 is a prime and q is a prime. Now if only we can factorize r plus q minus of r minus q, because we have different expressions for both of this, from p plus 1 equals to k whole into r minus q, and from the other equation, then we can lead to some solution. This can lead to some solution, right? Okay, so we'll try that. So first of all, r plus q is nothing but kp minus 1. If you remember that r plus q plus 1 was equal to kp, and let's just keep r minus q as it is. So this was the condition which we used, and then again you know that p plus 1 is equals to k whole into r minus q. So the two conditions that we found, we have to make them, put them to use, right? So we are again substituting for the value of p here, and we get this. Now once you get this, if you multiply out, you simply get this expression, which now is factorizable, because if you take r minus q common, you simply have k square minus 1, and you also have a k plus 1 here, and obviously k square minus 1 can be factorized again, and k plus 1 is one of its factors. So if you do the whole factorization, and since all of this is equal to 2q, you get this equation where 2q is equal to k plus 1 whole into r minus q into k minus 1 minus 1, correct? Now since q and 2 are both primes, because on the left hand side you can see 2q is given, where q is a prime, 2 is a prime. The only numbers that can ever divide, that can ever be factors of 2q, are nothing but 1, 2q and 2q. Those are the only combinations, because a prime can only be divided by itself or 1, correct? So 1 can divide this side, 2 can divide this side, q can divide this side, and 2q can divide this side, nothing else. So if that is the case, that means those are the same numbers that can divide the right hand side as well. So you can write 2q as a product of 1 into 2q or 2 into q and stuff like that. And you also have to note that k plus 1 is greater than or equal to 3. So you have to note that since k is greater than 1, this implies that k is greater than or equal to 2. That means that k plus 1 must be greater than or equal to 3. So this has to be kept in mind. Okay. Now let's equate the conditions one by one. So if k plus 1 is equal to q and the rest of the term is equal to 2, because left hand side can also be factorized as 2 into q. 1 into 2q is absolutely not possible, because if you put k plus 1 equals to 2q, and then this term cannot be equal to 1. Okay. So in that case, you simply have k plus 1 equals to q, cancel the q's off, and you simply get this equation from this equation. Solve it and put the value of k again, you get q minus 2 whole into r minus q equals to 3. And once you get a single prime on the right hand side, it becomes very easy, because then you know that 3 can be only written as 1 into 3 or 3 into 1, and you just have to equate the factors in some order. The possibilities are as follows, and for number 1 you simply get the value q3 and r6, and for number 2 you simply get the value q5 and r6. And both of these are not solutions to our equations, because r is becoming integer which is not a prime, correct? 6 is not a prime, so thus we discard these solutions. Okay, so k plus 1 equals to q is done. Now the only case we can check for is k plus 1 equals to 2q. If we do not get a solution there, then we can simply say that there are no solutions to this equation, right? Okay, now instead of k plus 1 is 2q and put the same value of 2q and k plus 1, you just cut them off and you simply get this following equation, where k minus 1 whole into r minus q minus 1 is 1. Now put the value of k, because it is 2q minus 1, and do the simplifications. These are basic simplifications. You get q minus 1 whole into r minus q equals to 1. This means that q minus 1 must be equal to 1 and r minus q must be equal to 1. So solving this, you get q equals to 2 and r equals to 3, and in this case q and r are both prime. Now it only remains to see if p is a prime, and if p is a prime corresponding to these values, then we are done, because this is the only possible solution left for us to even consider. If it does not work, it does not work. So p plus 1 is equals to k whole into r minus q, and put the value of k, because it is 2q minus 1 according to our case, and put all the values and you get p equals to 2. And therefore we can conclude that okay, we have at least one solution. Since 2, 2, 3 all these are primes, we have only one solution to the system of equation, to the equation p whole into p plus 1 plus q whole into q plus 1 equals to r whole into r plus 1, and the solution is this, where pqr is 2, 2, 3. So if you notice, we did nothing extraordinary in the whole problem, but this whole problem, this number theoretic problems are so creative and these are so mind-boggling that the amount of thinking and thought process that you have to go through to solve each of these problems is very tough. Okay, this does not compare to any calculus problem that you find in JEE Advanced or any JEE Mains or any undergraduate level exam, because those are routine questions. These are not. You cannot learn them, you cannot really have a way to understand them directly. So this is more like a class 7 student could also solve this, because he has the machinery. He might not be able to, because he may not have developed the vision for this or the wisdom for solving this problem, if I might add, but he can solve it, because you see nothing extraordinary has been performed here. It simply depends on the fact that okay, p is a prime, then 1 and p divide p, simply that, nothing else, nothing more. So number theoretic problems are very hard, and solving this kind of equations is also very hard, but this kind of questions, or at least trying to do this kind of questions at least once, every 2 days, giving it like an hour or so, this helps you develop a very good habit, and this helps you fundamentally much more stronger in logic, which is what required in any discipline of science. So I hope this session was helpful, and so I will try and bring other stuff as well for JEE Mains Advanced and ISI CMI. So this was a problem which I hope you guys liked. So let me know in the comment section if this was helpful, and I will see you